All right, we are now on our last topic for transformations. We've gone over translation, which is when you slide something on a graph. We went over reflection, which is when something flips across the X or Y axis or another line on a graph. We've gone over rotation and how to rotate around the point. So the last one is dilation. So we're going to go over what do you do when it asks you to dilate a point on a graph? So pull this up, go back to the beginning. All right. Transformation geometry, dilations. So what is a dilation? Dilation is a transformation that produces a figure similar to the original one by proportionally shrinking or stretching the figure. So what that means is you got your pre-image, and then when you dilate it, you have your image. Your image is going to be the exact same shape, but it'll be a different size. So they'll be the exact same picture, just larger or smaller. So it's kind of like when you go to the eye doctor and you get your pupils dilated. They put the drops in your eye and it makes your pupil get larger. That's what a dilation is. That's why they call that getting your pupils dilated, because it has to do with making it bigger or smaller. So a dilation is when something's the exact same shape, it just changes size. So dilated PowerPoint slide, same exact PowerPoint slide. It's not stretched out or anything. It's just the same thing, smaller. All right. So which of these are dilations? So you've got A. You've got two things of milk. You've got B, which is snowflake. C, Bart Simpson. D is the duck. So hint: same shape, different sizes. So if you look at those four, which one is the exact same picture? It's just bigger or smaller. So take a look, think about it. What do you think? B and C. A, not the exact same thing. This one got wider, but it didn't get taller, so it's not the exact same picture. This is the exact same picture. It's just stretched out bigger. The proportions are all the same. Same exact snowflakes, just one's bigger than the other one, and these are completely different. All right, so scale factor. This is the slide that matters the most. Make sure you pay attention to this. Scale factor is what you're going to multiply by to change the point. So the way it works is you'll have a point or an image on a graph, and then it's going to say, okay, this is the scale factor. And then what you're going to do is multiply that by the coordinates of the points. So if they tell you to multiply, if the scale factor is larger than 1, the figure is enlarged, so it's going to get bigger. So if they say the scale factor is 2, you're going to multiply all the points by 2, the picture will get bigger. If the scale factor is 1.7 or 8 or 32, it's going to get bigger. All right, your scale factor will never be negative. It's always going to be a positive number. If it's larger than 1, that means your picture is getting bigger. If the scale factor is between 1 and 0, which usually that means it'll be a fraction or a decimal, the figure is reduced in size. It'll get smaller. All right. If the scale factor is 1, that would mean it's going to stay the exact same size. So we won't ever have that. So if it's larger than 1, it gets bigger. If it's between 0 and 1, your picture is going to get smaller. All right. So let's take a look at what that means. So if we look, we have A, B, C, D. Are the following enlarged or reduced? So if you look at A, if the scale factor is 1.5, would this picture get enlarged or reduced? Would it get bigger or smaller? So remember what the last page said. Scale factor, if it's bigger than 1, your image is going to get bigger. It's going to be enlarged. If it's between 0 and 1, it'll be reduced. Your picture will get smaller. So let's see, scale factor of 1.5. What do you think? It's going to get larger. That's bigger than 1. All right. B, elephants. Scale factor is 0.75. What do you think? 0.75, smaller than 1, which means it's going to get smaller. C, you have the lion, scale factor of 3. 3 is bigger than 1, so it's going to get larger. And then lastly, scale factor of 1/5. That's smaller than 1, so your image would get smaller. All right, so let's look at some real examples of this. Dilations are used in everyday life. Uh, you want to make a model of something, a map. You've got a model for architects. It's the exact same proportions. They're just smaller. You got a video game arcade machine dilated to get bigger. This giant chair outside of this furniture store. Giant Big Mac. Same exact size images. They just get bigger or smaller. All right. So things to remember before we do some examples. Remember, a dilation is any resizing. The scale factor controls how large or small the figure will become. We dilate according to the scale factor. More specifically, we will multiply every coordinate by the scale factor. All right, so let's take a look at an example of what this is going to look like. Dilation is a pretty simple one, pretty easy. As long as you know your multiplication, you can use your calculator if you need to. So here's what one of your questions would look like. Plot the original points as indicated. Connect the points to make a right triangle. Then perform the dilation. So original coordinates. So we have triangle ABC with these 3 points. So if we graph these 3 points, they would give us this triangle. So we have triangle ABC. Now it says dilate by a scale factor of 2. So what that means is, first off, if it's a scale factor of 2, is this picture going to get bigger or smaller? Well, it's bigger than 1, so it should make this picture bigger. All you do, take the scale factor, and you're just going to multiply each of these points, each of these coordinates, by the scale factor. That's it. That's all you're doing. So take 2 and multiply each number by 2. So what's 2 times -2? -4. What's 2 times 4? 8. So there's our new point. So there's point A. Point A prime is now -4, 8. All right, B, times both of those by 2. 2 times 2 is 4. 2 times 4 is 8. That's all you have to do on these. You just take the scale factor and multiply the points to get your new points. All right, point C, 2 times 2 is 4. 2 times 1 is 2. That's your new point. So let's take a look. When I click, it's going to graph it. Should be the exact same shape, just bigger. And it is. It's twice the size. All right, so you're going to have the exact same picture, just twice as big. And what you'll notice is if the picture gets larger, the scale factor is bigger than 1, your shape's going to get farther away from the origin. Whereas if it's a scale factor between 1 and 0, and it's going to make it smaller, when you graph it, you'll notice it gets sucked in closer to the origin. So let's look at one where it's going to get smaller. All right, so we've got our triangle, points A, B, and C. Let's graph it. There's our triangle. So dilate by a scale factor of 1/2. So you're going to multiply all of these by 1/2. And then, of course, if you're multiplying by 1/2, that's the same thing as dividing by 2. So we just look and say, okay, we're going to take half of each of these numbers, either multiply it by 1/2 or divide it by 2. So what is half of -4? -2. What's half of 6? 3. All right, cut both of these in half. What's half of 2? 1. What's half of 6? 3. Same thing over here. What's half of 2? 1. What's half of 3? 1.5. And then when we graph it, it should make this picture smaller and closer to the origin. And it does. All right, so let's look at IXL and what these questions are going to look like for you. So if we have this problem right here, graph the image of triangle PQR after a dilation with a scale factor of 5. So what we're going to do is multiply all of these points by 5. So here's where some students are going to have some trouble. If you look at this and you get your points mixed up and you don't know, like, what point this is or what point that is, then you're going to have trouble. All right, so let's take a look. Move this over here out of the way. All right, so we've got the point. Which point is this? Point P is what? What's the coordinates? 0, 2. You go over 0, up 2. So that's 0, 2. And then you're going to multiply it by 5. So 5 times 0 is 0. 5 times 2 is 10. So our new point is at 0, 10. All right. Then we've got Q. What's the point for Q? Over 2, up 2. So it's the point 2, 2. And if we multiply both of those by 5, 5 times 2 is 10. 5 times 2 is 10. We have the point over 10, up 10. Point 10, 10. Now we have this one. What's this point? Over 2, down 1. So it's the point over 2, down 1, 2, negative 1. And then we need to multiply both of those by 5. 5 times 2 is 10. 5 times negative 1 is negative 5. So over 10, down 1, 2, 3, 4, 5. And there's our new shape. The scale factor is 5, which means it got 5 times bigger. And you see it got farther away from the origin because it's getting enlarged. All right. Let's take a look at another one. All right, here we go. Good. We got one with the fraction. So scale factor. Scale factor is 1/4. So you can either take your calculator and you can multiply by 1/4, or you could just divide each point by 4. So let's look. Point L. What point is that? Negative 4, 8. So negative 4, 8. And the good thing is, when you're doing these, you're not going to have to deal with any fractions or any decimals or anything like that when you're points. When you multiply by the scale factor, they're all going to give you nice, perfect points to plot. So you won't have to worry about that. So negative 4 divided by 4. Negative 4 divided by 4 is negative 1. 8 divided by 4 is 2. So this point is now at negative 1, up 2. All right, take a look at this next point. Over 8, up 8. So you have the point 8. Ooh, that's an ugly 8. The point 8, 8. Divide both by 4. 8 divided by 4 is 2. 8 divided by 4 is 2. So our next point is at over 2, up 2. And our last one is at over 0, down 8. So over 0, down 8. Divide both by 4. 0 divided by 4 is still 0. Negative 8 divided by 4 is negative 2. So over 0, down 2. So now we have the exact same shape. It's just shrunk down smaller. And you can see, since it's going to get smaller, it gets closer to the origin. All right. Last one I'll do, and then if you want to go ahead and start on your assignment for tomorrow, you can. It's 8th grade Q2. It's the one I'm doing right here. Look, we've done 2 problems, and we're already at a 23. You can get it to a 70, and that's it, and you can stop, and you'll get full credit. All right, so scale factor is a 2, so we're going to multiply all the points by 2. So we start at C, negative 4, and then 5. So that's the point negative 4, 5. So negative 4, 5. Multiply by scale factors 2. Negative 4 times 2 is negative 8. 5 times 2 is 10. So negative 8, up 10. Point D is at over 5, up 3. So over 5, up 3. Times them each by 2. 5 times 2 is 10. 3 times 2 is 6. So over 10 up 6. And then we have our last point, which is at negative 4, 4. So negative 4, 4 multiplied by 2, negative 8, 8. So negative 8 up 8. Negative 8, 8. So you see, same exact image, it's just larger. All right. Now, if you have any questions, email me, come to the Google Meets. This is the last one we're doing for dilation, and then we'll be able to move on. Save this. We'll be able to move on to taking the test, and then our next topic, which is scatter plots. So if you have any questions, let me know. Other than that, I will talk to you all later. Exit off of here.